understanding the concept of SN2 and SN reactions, we have to focus on this very important topic which can be asked in your upcoming exam, which is factors affecting SN2 and SN1 reaction. The factors which affect SN1 and SN2 reaction means the factors which favor SN2 reaction and the factors which favor SN1 reaction. So we'll try to just list out those factors, and I'll read out the points which I'm going to send you via Microsoft Word, and then we'll try to understand what is actually the essence of the points which you're trying to mention. The first thing what we are going to talk is about the introduction for this particular topic, that is the nature of the nucleophile, that is how the nucleophile it is strong or weak, nucleophile, the type of solvent we are going to use, and how the leaving group should be, what should be the nature of your alkyl halide, are the basic things which you are going to focus. When your solvent is polar, when the solvent is polar, aprotic, we are going to see that it favors SN2 reaction, which are easily shown by primary alkyl halides. The next thing in the category of solvents is if you have polar but protic solvent, that is going to favor SN1 mechanism, which is shown easily by tertiary alkyl halides. This is what we have already studied. The reactivity of primary, secondary, tertiary halide can be controlled by electronic and steric factors. There are several factors which determine whether substitution will be SN1 or SN2, and which also control the rate at which the reaction takes place. So we are going to discuss about various factors that will control the SN1 and SN2 reaction. The first one we are going to talk about is solvent. I'm going to write here for solvent. In this, as I said you, polar, aprotic. Aprotic solvents are those solvents which do not have hydrogen attached to it. For example, O-H, N-H are going to be the example of solvents which have hydrogen in it. But in aprotic solvent, you do not have this hydrogen. That is why it is called as aprotic, which do not contain proton. So polar aprotic solvent are used for SN2 reaction. Why? Because they are going to solvate the cation. And this leads to the activation of nucleophile. In the notes, it is said that it makes your nucleophile more naked or more available. It is actually, that means it is more available. So one thing to remember when you have going to talk about solvents category in case of the factors affecting SN1 and SN2 reaction. For SN2 reaction, we need to have a polar solvent as well as it should be aprotic. That means it should not have active protons. This leads to the solvation of the cationic part but not anion. This leads to activation of a nucleophile or availability of nucleophile, which makes it more reactive. Next one is polar solvents such as water or alcohol ROH contains hydrogen. That means it is polar protic solvent. So this polar protic solvent will favor SN1 mechanism, and they solvate as well as stabilize. They solvate and stabilize the carbocation formed. As we have already seen that carbocation is formed as an intermediate. So the formed carbocation is stabilized with the help of a protic solvent. And as you know that the SN1 reaction is more dependent on the concentration of the alkyl halide rather than the nucleophile. So if the nucleophile strength is also improved, it may not have any impact on the reaction. So the basic thing which we have to remember here is in case of SN1 reaction, the solvent will be polar but it will be protic, that will provide proton, that will solvate and stabilize your carbocation form, which will be intermediate. The nucleophile is also solvated along with the carbocation, but this has no effect on the reaction rate since the rate is dependent on only the concentration of nucleophile. So along with the solvation of carbocation, the nucleophile is also solvated in in case of SN1, but it does not have any impact in the rate of reaction. But in SN2 reaction, nucleophile is an important role because it is a bimolecular reaction. After the solvent, next is nucleophilicity. As we have discussed just now, the impact will be only in SN2 reaction. So the relative nucleophilic strength of incoming nucleophile will affect the rate of SN2 reaction, with stronger nucleophile reacting faster. So if the nucleophile is stronger, the rate of SN2 reaction is faster. The rate of SN2 reaction increases with nucleophilic strength of incoming nucleophile. The same point. In polar aprotic solvent, the order of nucleophilic strength for halide is fluorine is stronger than chloride ion, followed by bromide ion, followed by iodide ion. The rate of SN1 reaction is unaffected by nature of nucleophile. So in nucleophilicity, stronger the nucleophile, faster is the SN2 reaction. Nucleophilicity do not have any impact in SN1 reaction because it is independent of nucleophile. It only depends on the concentration of alkyl halide. After nucleophilicity topic, next is leaving group. Whatever we have studied in SN1 and SN2 reaction, those we are just trying to generalize here in various side headings. So leaving group, as you know that the reaction rate of both SN1 is increased with the leaving group is a stable ion. So it should be leaving group should be stable and also should be a weak base. The nature of the leaving group is important to both SN1 and SN2 reaction. The better the leaving group, the faster the reaction. So if the leaving group is better or stable, I should call it, I think, stable. Better is the reaction. In transition state of both the reaction, the leaving group has gained a partially negative charge. We have seen that in we have partially negative charge on the leaving group as seen in the example, and the better that can be leaving group has again partially negative charge and better that can be stabilized, the more stable is the transition state and the faster the reaction. So the partially negative charge on the leaving group should be stable and that will actually increase the reaction. Therefore, the best leaving group are the ones which form the more stable anion. So the leaving group are categorized as best if the anion, that is negative charge, is stable. This is also related to basicity in the sense that more stable the anion, the weaker the base. So if the anion has to be more stable, the base should be weaker. This is the thing we need to remember. If the leaving group should be categorized as base, the anion should be stable and the base should be weak. We have an example for these that iodides and bromides are stable ions with weaker base. Bromide ion and iodide are stable anion with weaker base, whereas chloride is categorized as less stable and more basic. That is why it is poor leaving group. So in leaving group, as we said, we are going to focus on stable anion weak base. Then that stable anion weak base are bromide and iodide, whereas chlorine is having more basic and less stable. That is a poor leaving group. So the leaving group should be more stable and weaker basic. The fluoride ion is very poor leaving group. As a result, alkyl do not undergo nucleophilic substitution reaction. Iodide is better leaving group than bromide, and bromide is better leaving group than chloride. So iodide followed by bromide followed by chloride is a better leaving group. Next is alkyl halide. In case of alkyl halide, in case of SN2 reaction, tertiary alkyl halide is less reactive by SN2. As we have seen, primary alkyl halide will be more reactive, followed by secondary, followed by tertiary. Tertiary alkyl halide is less reactive than primary or secondary, since the presence of three alkyl group linked to the reaction center lowers the electrophilicity of the alkyl halide by inductive effect. So as you know, in tertiary alkyl halide, you have three methyl groups which are electron donating, and this is your halide. So when you have electron donating group present, the electrophilicity, that means that X is more electronegative, and due to more electronic charge on carbon due to donation of this electrons, removal of X as X minus will be difficult. So that is why removal of X, that means that due to inductive effect, or as we have already studied, this concept is shown in inductive effect. When more electron donating groups are there, removal of X will be difficult, because when more electrons are present here, so the removal of X will be difficult. So that is actually making tertiary alkyl halide less prone to SN2 reaction. The one more factor is that in SN2 reaction, as we have seen, backside attack will be there. So due to this bulky group present, there will be steric hindrance. So incoming nucleophile cannot come and attack for the formation of a new bond. So tertiary alkyl halide have three bulky alkyl group attached to the reaction center. Reaction center here in the notes is nothing but carbon, which act as steric shield and hinder the approach of nucleophile. Primary alkyl halide has only one alkyl group attached to the center, and so the access is easier, and that prefers or helps in the SN2 mechanism. In the alkyl halide section where we are talking about SN1, it says formation of planar carbocation in the first stage is favored for tertiary alkyl halide. We see a transition state where you will have three bonds, and if you have CH3 attached, as we have seen in the mechanism for SN1 reaction, this will favor the incoming nucleophile to come and attack via both ways, and it relieves the steric hindrance. The carbocation is also more accessible to the incoming nucleophile. That means it can attack from both the sides. The formation of carbocation is helped by electronic factors such as inductive effect and hyperconjugation. Such inductive effect and hyperconjugation is greater in carbocation formed by tertiary alkyl halide than those formed by primary or secondary. So in SN1, tertiary alkyl halide is followed by secondary, followed by primary. The concept of hyperconjugation and all, we don't have to go into deep. The only thing is they are or electronic factors which are actually helping the mechanism for SN1 reaction to follow this order of kinetics where tertiary alkyl halide is followed by secondary followed by primary. The last topic is determining the mechanism. In it is generally fair to say that nucleophilic substitution reaction of will take place via SN2 mechanism, whereas nucleophilic substitution. So what it is telling in this topic, that is determining the mechanism. If we have primary alkyl halide, it shows SN2 mechanism, and if you have tertiary alkyl halide, it shows SN1 mechanism, depending upon the factors what we have already studied. The carbo In general, secondary alkyl hydrides are more likely to react by SN2 mechanism, but it is not possible to predict this with certainty. But about secondary alkyl halide, it can be by SN2 or by SN1, depending upon the conditions we supply. If we have polar aprotic solvent, then it gives SN2. If we have polar protic solvent, it gives by SN1. This is all what you are going to study in this factors affecting SN1 and SN2 reaction. This is very simple. The notes I am going to send you, please see the video. I am just trying to generalize a few important things from the notes which I am going to send you now. And this is very important question for your coming exam. Thank you.